So the thing we need to figure out here is, when do we use the law of sines, when do we use the law of cosines? And this tells you the law of cosines is the best choice if either of these two things. So case one, the length of all three sides of a triangle are known and you're trying to find an angle. So if you don't know all three side lengths and you want to find an angle, then use the cosine law. And it's the one that looks like,
So if you're trying to find cosine A, you go
cos A,
plus C squared
yeah.
minus A squared over 2BC.
Right. It's this form of the cosine law. If you're given all three side lengths and you want to find an angle. Cosine law is also the best choice if two sides and the enclosed angle are known. So you look at this one, you have this side, and where those two sides meet up, you also have that angle. That makes it the enclosed angle. So two sides and then the angle in between those two sides that you know, then that's the cosine law. But that's the other form of the cosine law, right? It's the a squared equals b squared plus c squared minus 2bc cosine A. So those are the two situations where you would use the cosine law. If you have all three sides, or if you have two sides and the enclosed angle. Law of sines is the best choice if, and these are the next two cases, case 3 and case 4, two sides and an angle opposite one of those sides is known, and you're trying to find the other angle. So here we have these two sides, but we don't have the enclosed angle, so it's not going to be cosine law. You have one of the other angles. And really, to use the sine law, what I'm looking for is this angle side pair, where you have an angle and the side length across from it. If you have that pair, then you can use the sine law. A side length and its opposite angle. For cosine law, you're not going to have that. You're not going to have a side angle pair opposite each other. But this one, yeah, two side lengths and one angle, then you can use the sine law to find the other angle. Or case 4, two angles and one side are known, and you're trying to find the missing side. But again, we're looking for that pair. 15 and 22, that's a pair, opposite angle side. Pair, but two angles and one side length. Then you use the law of sines. And it says here in the bottom, in general, law of sines is easier to use. Most people find it easier to use. So always check to see if you can use it first. I wouldn't necessarily say that it's easier to use the sine law, but what I will tell you is if you don't know which one to use, try one of them. If it doesn't work, then you have to use the other one. So it's good to know when to use each one, but really, if you can't remember and you're looking at one and going, I don't know which one to use here, then just try to use the sine law or try to use the cosine law. If it works, it works. If it doesn't, then use the other one. And you'll know right away if it works because you'll have all the information that you need to fill in. Or you can find all of the information. You know, you could have something like this, which doesn't really fit one of those cases. A triangle like this where you have, let's say this is 60 degrees and this one's 58 degrees. And you have this, you want to find this, no, let's see, because that would be the same case. You have this, and you're trying to find this. This one's a little different, but it's still two angles and a side length. It's just not the opposite. You don't have that opposite pair. But you can easily find it, right? So in order to use the sine law, you'd need that angle, but you can easily find that angle just by subtracting from 180. So you don't have that pair that I'm talking about, but you do have enough information to easily find it. Then that's the sine law. So that's kind of a different case, but it's still two angles and one side. So two angles and one side, it's going to be the sine law. But again, like I said, if you just don't know, well, that's okay. Just try one. If it works, it works. If it doesn't, it doesn't. So let's have a look at this application question using trigonometry and probably the sine or cosine law, since that's what we've been learning about. It says Juan and Romella are standing at the seashore 10 miles apart. The coastline is the straight line between them. So I think I'll just start by, all of these you're going to want to draw something, right? So I'm going to just draw the coastline. Oh, let's make it blue since it's water. And we'll put them both on there. Here's where Juan is, and here's where Romella is, and they're 10 miles apart. It says the coastline is a straight line between them. Both can see the same ship in the water. So there's a boat like out here in the water, and they can both see it. Do you like my artistic ability? Yeah, it's good. The angle between the coastline and the line between the ship and Romella, oops, I skipped one. The angle between the coastline and the line between the ship and Juan is 35 degrees. So that means this angle in here is 35 degrees. The angle between the coastline, which is down here, along that horizontal, and the line between him and the ship. That's 35 degrees. And then it says the angle between the ship, the coastline and the line between the ship and Romella is 45 degrees. So that's this is 45 degrees. And it says, how far is a ship from Juan? So this over here, I'm just going to label it as X for now, is what we're trying to find. Actually, maybe we should label it as R, since we already have that point labeled as R. So that R is what you're trying to find, the distance between Juan and the ship. This diagram is not drawn to scale at all, obviously. I just slapped some lines down. So it is going to be a little bit tricky to look at your answer and say, is that reasonable or not? You could measure out some angles with a protractor if you wanted to have a more accurate diagram. Like my angles are definitely bigger than 45 and 35. But let's see if we can figure it out. So, are we going to use the sine law or are we going to use the cosine law?
We can use the sine.
I'm going to call that S. Yeah. We're going to use the sine law, but we don't know the angle that we need to know, but it's easy to find, right? 180 minus 45 and minus 35 will give us this one, which is 100. Once we have that 100 degrees, then it should be fairly easy to find, to use the sine law and find what we're looking for. So we're trying to find R. I'm going to start with R over sine R. And then because we know side S, I'll go S over sine S. Remember, this one is what you're trying to find. This one is what you already know in terms of side lengths. Then we'll just fill in the rest of the information and solve. So it's going to be R over sine 45 equals 10 over sine 100. Multiply by sine 45. Gets it out of there. Multiply here by sine 45. You get the idea. And we'll get an answer.
That's 7.8.
You got 7.18? Yep, so did I. So we get R equals 7.18 miles. It doesn't tell us how to round it, so it doesn't really matter.
If it's 7, or
If you called it 7, I probably wouldn't round it to a whole number. I'd probably call it 7.18 or 7.2. But it doesn't tell us, so it could be. Okay, Jack is on one side of a 200-foot wide canyon and Jill is on the other. Jack and Jill can both see the trail guide at an angle of depression of 60 degrees. How far are they from the trail guide? So there's this canyon. Let's say that's it. And Jack is on one side. I'm going to call him A. And Jill is on the other, and I'll call her B because I can't call them both J. It's 200 feet wide, so if I draw in that line between them, that's going to be 200 feet. And then it says they can both see the trail guide at an angle of depression of 60 degrees. Last year you learned about angle of depression, and it's if you're looking down at something, it's the angle between your line of sight and the horizontal. So if we put the guide down here, then we can draw in these sight lines. That's the guide. We'll just call her C. So that means that 60 degrees is in here and 60 degrees is in here. So we're trying to find how far are they from the trail guide. So we could find either A or B because they're going to be the same. It's an isosceles triangle. It's actually an equilateral triangle, right? So we could probably figure it out pretty easily. Since we know that this is has to also be 60 degrees. We actually don't really need to do any work there, right? How far are they? 200. But if we actually do it just quickly to see how it's going to go, say we're finding A, we'd go A over sine A, which is 60, equals C, which is 200, over sine C, which is also 60, and we'd end up with 200.
Yeah.
Kind of a silly question. Tom, Dick, and Harry are camping in their tents. Okay, so there's 3 tents. We'll put them here, here, and here. It doesn't really matter where I put them as long as it's 3 tents. If the distance between Tom and Dick is 153 feet, the distance between Tom and Harry is 201 feet. And then the other distance, it says, is 175 feet. What is the angle between Dick, Harry, and Tom? Which angle are we actually looking for here? T, D, or H?
What is that?
We're looking for, starting from D, going to H to T, this is the angle that we're looking for. So we want to figure out what angle H is. We're given all 3 side lengths. We need to use the cosine law. And we're going to go cosine H equals D squared plus T squared minus H squared over 2 dt. So cosine H equals 201 squared plus 175 squared minus 153 squared over 2 times 201 times 175. And then it's just using our calculator. So once you've worked it out and you've even done the second cosine and everything, you should end up with angle H is equal to approximately 47 degrees. So here's one more question. 3 boats are at sea. I want you to read it and try to make a diagram. and then we'll go over it together after you've tried. Your diagram should look something like this. A, B, and C might be in different spots, but the distance between A and C is 4, between A and B is 2, and angle A is 45. And then we need to find side A, and because we have two side lengths in the enclosed angle, that's the cosine law. A squared equals B squared plus C squared minus 2BC cosine A. So we'll do 4 squared plus 2 squared minus 2 times 4 times 2 times cosine 45 degrees. A squared, I get 8.686, and then when I get A, 2.9 miles. 2.947 is what I get, and then it continues. I'm going to call it 2.9. You might call it 3, or you might call it 2.95. It doesn't tell us what to round it to, so it's your choice.